everyone, just wanted to take a minute to talk a little bit about the solutions to quadratic equations. In particular, in this video, we're going to focus on the solutions to quadratic equations as determined by a graph or a table. All right, so just a quick overview in terms of what the solutions to a quadratic equation are going to be. If you were to graph well, really, there's three options. Let me start there. There's three options for what could happen. You could have no solutions, right? If you think about it, when you start squaring things can get a little bit interesting with positives and negatives. So there could be no solutions. There could be only one solution, or you could have two solutions, all right? So the way that we represent the solutions to a quadratic equation, they're represented by the zeros of the function. All right, so if I had a quadratic function, the x-intercepts are essentially going to be my answers to the corresponding quadratic equation. All right, so you can think of them as the roots, the zeros, just the x-intercepts. Those are all the same thing in this kind of instance, right? So we're just looking for the x values. So when we have two solutions, as you can see on the graph, that's going to be a situation where it crosses the x-axis twice, right? So in this case, it crosses at -4 and it crosses at 4. Okay, so this is going to be a situation where you have two solutions, and this is kind of the one that you're going to see very frequently for our for where we're at. It's pretty much going to be anything that has a parabola that is opening up that has a vertex below the x-axis is going to have 2, and a parabola that is opening down and has a vertex above the x-axis will have 2. All right, so there's a couple different ways you can end up with it, but ultimately, as you can see here, this could be something like x squared plus 16 or minus 16. Pretty much anything that's going to have a vertex below the x-axis and open up, or a vertex above the x-axis and is opening down. But anyway, this is how you would see there's two solutions, right? You look at the graph, you find that it intersects twice, it has two solutions. For one solution, this is going to be where the vertex is on the actual x-axis, right? So when the vertex is touching the x-axis, or essentially the y value of your vertex is 0, this is only going to have one solution, right? It's going to essentially touch the x-axis and then bounce off and continue on the other direction, right? It could be, kind of approaching this way and do that right at the x-axis. But ultimately, the only place where it's going to intersect the x-axis, and therefore the only solution, would be at the vertex itself, right? So we're looking for, here in this case, 7. And I'll kind of leave you to think about why that might be the case, about what will happen going forward. But ultimately, that leaves us with the last situation when we have no solutions. So a no solution situation is going to be where it never crosses the x-axis. Now, we really have not been encountering a lot of these, because so far we kind of were talking about, like factored form, where we had the roots and things like that, vertex form, and we weren't necessarily looking at the this kind of situation as much, but now it is something to be considering of, right? So this, if we graph this, it never touches the x-axis. So if we're calling the solutions, right, the x-intercepts, there's no x-intercepts, and that's fine. There's nothing wrong with that. It's just that means we can't say that there's a solution, but there's not, right? There's no solution. So this is what it's going to look like. And additionally, right, if you had a graph, if it was all entirely down here, right, there's going to be no solutions. So pretty much if you have a vertex above the x-axis when it opens up, or a vertex below the x-axis when it opens down, you're going to have no solutions. All right. So essentially, what you're going to do is, if you look at these graphs, you can identify how many solutions they have. All right. Now, really quickly, how would you find that if you were dealing with a table situation? So if you got a table of values from a graphing calculator, or you got a table of values because you just happen to have the tables, what you would do is you would look for the areas where the y's were 0, right? So if you had a y equaling 0 here and a y equaling 0 here, well, you know there's two solutions. There's 1 and 6, right? Because, again, it's just the x-intercepts, and you have x-intercepts when y is equal to 0, okay? So that is ultimately going to be what you see. Now, let's say, for instance, you saw something like this. I don't know, 2, negative, 1, negative 0.1, and then you had 3, and you had 0.1. Well, okay, we don't know exactly what the x-intercept is. However, right, this is between, right, if here's negative 1, negative 0.1, and here's positive 0.1, we know somewhere in between there it hit 0. So if you get something like this, you don't know exactly what it would be. However, you know it'd be between 2 and 3. So it's always good to keep that in mind. Just be careful, though. Remember, you're looking at where y is 0 or close to 0, and the corresponding x would be your answer. All right. So that is just a general overview on the potential number of solutions and how to identify solutions based on a graph or based on a table. So ultimately, we are going to show a number of different ways to use these, but this should be a nice kind of overview to get you started. So let me know if you have any questions, and have a great day.